Okay, with a bit of delay, we are kind of online. It seems we are not completely online because this camera is dead. Let me check if I connect and disconnect it, if it works. I don't know. Setup is a pain. No, it doesn't do anything. Let me quickly try to fix that. Yeah, I'll just restart OBS. I'll be back soon. I can still use my multimeters at the same time. Connecting, that seems to work. Okay, so don't try to do both camera at a time. So back in business. A friend of mine found this on the street, was laying around, and this is an e-scooter bike. Oh yeah, e-scooter bike. You just plug it. Here we can see the top. So it is produced by, I've seen the brand somewhere. No, here. It's produced by OKAI, and it is licensed by plenty of e-scooters. That's the model number up. For those interested, this is RPH 0002, 46 volts, 47 volts. And actually what's more important is that, yeah, 47 volts, that's nominal capacity, 14.7 ampere hours, max charge current 5 amps, and 55 volts almost. And yeah, I already, it's been a long time since you found it, but the problem was that you couldn't unlock it. You couldn't unlock it. There's a battery management system, we'll call it BMS, and I wasn't able to say to BMS, okay, now provide power, because that's really a lot of power. We see that this is 50 volts. We have almost 50 ampere hours, and you can probably directly tap on that. I'm not sure if there is maybe there is some kind of a current limits which you can draw, but it is pretty high because you need beefy motors to advance. This is why, but per default, the outputs are disconnected. So if it lands in water or if some dirt goes in, then nothing happens. And this is taken care by the battery management system inside there. And this, does this still work? Yeah. So you can see that it is still as 44%, 48 volt, temperature, okay. And here it's the LED says if it's red, if it's too low. I think at the beginning it was at 90%, something like that. And obviously with time it drops, but not too much. And I already took it apart and I already did my research and found out that so every battery, there's no one way to unlock or to free the batteries to make the battery accessible. Every battery management system has their own way, and this one uses was pretty new at the time, and it doesn't use one of the new art unlocker, battery unlocker. It used CAN instead. And yeah, the codes weren't known by that time. Now they are known. And does the audio actually work? Up, let me have a feedback. Yeah, it works. Now they are known. So we'll still take it apart I'll show you what's inside. Even if I already done it, we still need to access it. So on the back, there's this huge board with kind of spade connectors. We'll not use it too much. Up. I don't know what these holes are, just for the screws. Okay, there are pictures of that online which you can find. I'll link a forum entry. Here on top there's nothing too much interesting. It's mainly a board to indicate the voltage and so on, but this is not where you can access the device. This is on this part, so let's open it. Stick a screwdriver. Yep. Let's open the back. So there's a complete separate board here which talks to the BMS and to get the voltage. I'm not sure. Yeah, probably talks to the BMS. Does it? I I should have pictures of that actually. Let me check the pictures I have. Projects to do, I think. Or done. Here. Yeah, I have this battery since June. Pictures. Let me check if there's something incriminating. No. I'll show you what's inside on the front here. Up. Full screen? Yeah. So this is what's on the front. Everything is potted. Also on the other side, everything is potted probably for water ingress. But here you have cables going there, and on this board and here there's a small microcontroller. I think I removed the sticker. Yeah, I did. Oh, here. Wow. These are spark distance. Why would they want? There is no 1000 volts. That's weird. Here we have this microcontroller. I don't know this brand. I don't know this logo though. It's not part of my database. Just to find out something. TMI 1621. TMI 1621. I didn't spend too much time on this thing. Simply, okay, it's a CMOS driver. Okay, a CMOS. Titan. Yeah, I know Titan, but this is not a Titan. This is something else. And this is not TM, this is TMI 16. Okay, this is not the right one. But it probably has an LCD driver. TMI, not TM. TMI. Nothing. No one knows this chip. Battery autopsy. Okay, that's the forum. So people already did a battery autopsy of this OKAI E400B. This is the 400B. There was an unlock code over UART for the 400A. This is the 400B, and actually this is, so yeah, someone tried to, there's a lot of energy. You have plenty of these cells, and probably you see here, this whole thing is the BMS, battery management system, and on the back you have plenty of batteries, and here it seems that he got it ignited, so it's a bit dangerous. Here you can see all the batteries. I didn't completely remove the potting. This is the LCD controller. Here again the TMI, but there's a TMI similar, TM, and yeah, I think it's very similar. And here it includes LCD controller for the LCD on the back. Okay, no, it's not this post where there's the code, but that's not too interesting. But it would be interesting if it actually talks CAN to figure out the voltage. In order to do that, I try for OKAI CAN bus or sniff SPI connection between the board and display. I can't really find anything. Okay, maybe not. So that's the chip on the front, where there's the LCD. But this isn't where you unlock the things. This is just a display. It would still be interesting to find out if it talks CAN and if you can sniff it, although you won't have the codes to open the connections. So let's go back to the bench and let's open this device. It's on the back. Oh, I remember the super long screws. I hope it still works. And these are Torx. So the one with the hole in the middle, these ones. But I'm not sure if it's exactly this one. Ah, it is. Wow. First fit. Oh, it's not possible. No, it's not this one. No, it is. No? Too large? Is it the smaller one? No. Still too large? No, I wouldn't guess so. Let's try to find out one that fits. Actually, I don't need to open this. I only need to open this thing. And they're probably the same screws. So this is the right. I already opened it previously and there's not too much interesting. There's lots of putting. I didn't completely remove the putting to have a look at the BMS, and the BMS is huge. It's this whole board. Must have been quite expensive. Up, and although I took it apart in June, at that time there wasn't any code to unlock it, but since the community is quite large for reselling and for other purposes, because the battery at some point die or companies get removed or so on. So yeah, you already see I did some work. I removed this. So here we have the battery connections, and I even draw what is connected to what. Here is a board with the black thick. This is probably the ground one. This is probably red thick wire. Okay, it's this. Okay, this is the way. Red thick. This is probably 48 volts. And some you can also buy from OKAI. You can buy this battery. And here I tried to figure out. So what we know here is that these two are ground. This is probably 48 volts. That should be between 1 and 4. 1 and 4. 26. Okay, 26. Probably because there's not a lot of charge because the BMS is not open. So we don't care about this connector though, because I don't have this connector. We care about this connection. So I do have to open it. Up. Although we could create some spade things, but who cares? Okay, maybe. How did I open it? I know I did open it, but here it doesn't fit anymore. So I'm wondering how I did that. Did I use something smaller that fits like that? Maybe the screw here is already gone. That's weird. Oh no, now it's unscrewing. So let's mark the screws. These are the connector screws. Let's get, where are my mats? I think they're here on the back. Here. Up. This is bottom connector. Up. Another way you could do it is just replace them in the screw holes, but then you have to unscrew and rescrew again. I'm too lazy for that, but that's another solution how you can organize the screws. I just write them down. Up. Maybe I will even completely not use this bottom part to save some space. I don't know. Yeah, I'll just have some connections going out, but I'll show you what the connections are, and it's probably easier to test it while it's open. Are they all the same screws? This would be interesting to know. These screws are so long. Expect that I'll have to use. I do have somewhere this machine. Let's try to use this for the screws because I'm too lazy. And this is an electric screwdriver. Not a lot of torque, but you don't want to strip, so it's plenty fine. For the lazy guy. Huge screws. This is for the slide, bot slide up, and we have a second one, which is already there. This is unscrewed. Da, da, da. This is unscrewed now. That's unscrewed, and we have this one. Now we can remove this part. Are they the same? Yeah, they're the same. And they're probably the same as this one, yeah, but we don't mix it. This is bottom cover. Bottom cover. And here you can see the cells. I did remove some putting to figure out what it was because I didn't have the pictures in the beginning. And here you can already see, let me turn this. Here on the side you can see the board. And the board goes from here up to the complete other side, which you've seen on the picture from the forum where it burned down. So just the board cost must be pretty expensive because it's large. And so we have three things. We have this. So what I figured out is that generally this is to discharge, and if you want to charge, you actually don't use this ground, you use this ground. I have no idea why though. Why you wouldn't use this ground? You need less current, but why wouldn't you use the complete one? So this thing here was just connected to these connectors. We don't need this anymore. We can directly solder to these connectors. And this goes to the board. This is the connection, and by testing the connection, I figured that there was no activity here. This is that, interconnected, black, is there something? Yeah, black, orange, and green, yeah. There was no connection between them. Here, black and green, 3 to 3 volt, okay. Current draw possible input. Same for orange, no pull up or down. So there's no pull up or down, and this already means that it is probably not UART, but some differential signal. On UART, often you pull up the receive pin. And yeah, so here there was no pull up and pull down. And there is no activity. I tried providing serial communication. I didn't get any response. It can still be serial, but I don't think it is. I really think this is a CAN, and CAN is used a lot for automotive, so why not use it for batteries? I think CAN is now, the patent is now free, and it costs a lot less. And it's a very robust protocol, and that's why we use it in automotive. And here, pulse probing. So what was interesting here is that when you probe the pins, you see the 48 volts, but as soon as you put a load on it, it's gone. Let me try to probe the pins. I hope the display, the multimeter display still works. 24 volts, okay. And you already also see it. But it doesn't hold. As soon as you put a tiny load, it will drop down. Yeah, 26 volts, and we can try it just with 1K resistor or things like that. Let me get a resistor. Resistor through hole. Up. Just 1K should be plenty sufficient. Up. 1K resistor. Soon I will connect to it. See, nothing anymore. If I remove it, we go back to the 24 volts. This is simply because the output is not connected, but there's still some leaking current, but very, very little leaking current. And actually, why here? What's the difference with here? This should be also the ground, and this is completely, no, okay. This doesn't provide any energy, so let's remove this for now. This was protected because I couldn't use the battery. Now I can use the battery. Up. Up. And now I will use the battery. So here again we have the 20 something volts, 23 volts, and here nothing. So this charging pin is probably not even connected, and this output pin is just slightly leaking. Maybe to detect that there's something. And yeah, so what we need to figure out was the message to tell the BMS, which is inside the battery, please connect the battery output so I can drain the energy or recharge it. I don't know if it's the same. Maybe they just connect it completely. And there are several ways to do that. The easy way, well, the best way would just to go to a charging station or to have one of these e-scooters and tap on the communication and listen to everything which is going to the bus, and then replay it if there is no authentication, message sequence number, or so on. Depends how secure it is. I don't think this is an e-scooter battery. There's no need to have something which is pretty secure. So probably there's no authentication. There's no signature or something like that. There's no sequence number, which is important to respect over time. It's probably just the same messages to open and close a thing. CAN is not meant to be a secure protocol. It's just meant to be reliable between components. And yeah, because there was no pull-up and because they didn't react to anything, I thought it was CAN, and I didn't have the e-scooter to tap the communication from. I just got the battery from the friend, that's all. And I waited until somebody does it. I didn't want to spend some more time, and because the community was large and somebody did it. We will get to this forum where I get information from, and they already even provided a template or code to do it. So let me find it again. Check. This doc forum. This. Up. So let me show you. Actually, I have even other pictures. Let me scan the pictures before. Okay, this is the wrong one. The connectors are now. Let me share screen, full screen here. So this is a connection from another battery pack. So I looked around to find if somebody found it, and we don't have these two connections. The power connection is not the same. We've seen that it is a big one. It is still 13S13 because the nominal voltage is 3.7 volts. So if you divide if you multiply 3.7 or 3.6, let me check. 3.6 times 13, because they're in series, so 13S means 13 batteries in series. Yeah, 3.6 times 13 is 46.8 volts. So this is the nominal voltage, and the high voltage is 42 volts. This is the maximum for lithium batteries, 52.6 volts, and this is what was written on the battery. So this way we know it's a 13 series battery pack, but we don't have these connectors. Still, they also use CAN. Also here, it's probably, this was also by OKAI, but another model. This is the BMS. So somebody opened it, lots of work, removed the potting, lots of work, and found this battery management system. You see beefy transistors or beefy MOSFETs. Here on top you have the connection for the LCD screen. This is the microcontroller, and these are the connections on the bottom. You see how large it is? The batteries are directly tapped on it. Oh, here we have, actually they do have, the last one is Charge Plus. For me it's black. Is it? Yeah. I have two blacks and one red. Maybe the second plug is also to charge. To charge, you can, maybe this allows to charge, to have a separate monitor charging, because charging is limited to 5 amps, but the output is definitely higher than 5 amps. And that's why you probably have another output, so you have a safety charge, which can be cut off, because here you tap directly on the batteries. Huge boards. On the back, there are even some things, huge bars. This is not the right connector. So everything I got here for was from the forum. I didn't do it myself. Ah, here. BMS. This is the connector we have. Somebody found something out. Bypass. What bypass? I don't know. So that was it. So let's go to the forum, and here, if you want the same results, just here is the URL. Here's the URL, and just look for tier ES400 unlock development, and they're also talking about E7P. So somebody reversed it, sold it, someone else just published the code, although it's not his right to publish the code. So here we have the hex file for an Arduino with an MCP2515 CAN controller. What we can do is just use the hex, flash it to Arduino, and see if it works. Arduino Nano. And that's what we will do, actually. So yeah. And later on in this forum, there is actually the source code, and we'll have a look at the source code afterwards. I didn't yet. So we need dev boards. Dev board box. And for that, I like to use, I have always this, yeah, this is the right microcontroller, 328. So this is an Arduino board. I actually I only use it for people who have already written code for it. Yeah, 328p. So we will use this. Else I don't develop code on that anymore. But yeah, if there are people who did, then it's pretty useful to have it. Like here, we can flash the code and just run with it. Yep. Afterwards, we need I think it's an IC. I don't remember exactly, I could check, but it's probably in my IC box. Integrated circuit, there's probably a CAN controller. And let's actually here, that's a CAN controller, 16 megahertz. I probably modified it. And here we have this MCP chip, MCP 2515. This is because this microcontroller doesn't have a CAN peripheral, so it talks to this one over SPI. Here is the SPI connection, and this one can then dock CAN, and afterwards you still need the CAN transceiver, because CAN is not a TTL CMOS level. It's not between 0 and 5 volts or 3 volts. It's a differential signal. And because it's a differential signal, you also don't need ground. You need just plus and minus, or high and low. And here is just to put a termination resistor. I'm not sure if we need it. I think it's 120 ohm. So we will need this. And actually, yeah, I have connections for that. So let's find DuPont cables, male to female. Up. Here there's only one SPI port, or maybe two. There might be the code written somewhere. Standard SPI, interrupt is pin D2. Okay, we will have a look at the data sheet and try to replicate it. So, this should be plenty enough. Switch these two around because I like to have black. Oh, it's actually just the right number of pins. I can already try to flash the code though. Although, will it do anything? Does it blink? I don't know. Up. What is J1? I didn't write it, or maybe should have looked. at the hardware. Let's zoom a tiny bit. Here we have that. This we don't need anymore for now. This we can put to the side. Up. This we also don't need anymore. Datasheet. Let's get the Atmega datasheet. I have it somewhere. So, the bench. So we will split. We'll see the screen and the badge at the same time. And let me find the datasheet, which I will put here then. Sheets, microcontroller A228B summary should be enough. Data sheets in the project. Up, thank this and 2. You should go to 1. Here we have a look at the pinout, pin configuration. So this is the datasheet for the Atmega 328P. And if we see pin configuration, pin description, F9, we have this one, and probably there's only one SPI port. Yep, here it is. Here we have the pins. Clock, MISO, MOSI, and it should be CS chip select, but they named it SS slave select. Probably. So let's connect that. I'll write it down also on a piece of paper, so I have it for later on. I just need a piece of paper. Paper. Pen. There are two versions of this board. There's a 8 megahertz and a 16 megahertz. And I think it's just about how fast the CAN can talk, because CAN, like UART, doesn't have a set baud rate. You can change the baud rate, and every component. So here, CAN is a bus, so plenty of devices can go on the same 2 lines, but they all have to use the same baud rate. Although maybe you don't have to. They could mix, but generally you have all on the same baud rate. So we will have the SPI part, SPI PB. I'm just writing down. PB5 is SCK. Then we have P. Is it actually written what is what? No. I love it. I have to figure out which pins are connected to what on the digital pins. PB4 is MISO. MISO. PB3 is MOSI. And then PB2 is SS. It's probably chip select. PB2 SS. Plus minus we have. And then the forum said something about the interrupt being on D2. Okay. And I'll have to write out which pins this correspond to. Interrupt is D2. Do we have this here? So we have interrupt, slave in, slave out, chip select, ground voltage. Okay, that's all. That's pretty easy. So now we need to figure out which pins are that. I should have a data sheet for this board also somewhere, probably. Or we'll have to look the schematic for the Arduino Duo something. No, I don't have it here. MCU, no, I don't have it. How do we know? So let's download it. Schematic. Do we know do something I have never? Due mi Lenove? La Nove? Due mi la Nove. Probably Italian. Like the logo there is. Does it stand for something? Or is it a made-up word? Schematic. We should have it. Now we have it. Okay. Let's switch to this up. And here we see the SPI. Digitals. These are probably 13 and so on. Yeah. So SCK is on digital. SCK, this is D13. Then we have MISO, which is D12. MOSI is D11. D11. And MISO is D10. D10. And then why did they put on D2 and not on something else? I don't know. But not that important. So we have power. Is this 5 volts or 3.3 volt? I don't remember. Maybe both of them? I don't know. Let's get the datasheet for this IC. This is the MCP. I should have it. I do. I did have it. IC. I did have the datasheet for that. Just under the wrong name. It's not an IC, it's a dev board. But I still need the IC microchip MCP. So the MCP says that it is what's the input voltage? 5 volts. And probably this microcontroller is also 5 volts. No, although there's a regulator. Here there's a tiny regulator, so it's operating at 3 volts. Oh, this is just one. No, this is a regulator. And still, we have to provide 5 volts to it. Let me check again. Voltage supply. Up to 7. No, this is maximum rating. I don't want the maximum. I want the VCC characteristics. VDIF can. The difference between high and low is 3. That's okay. And I don't find it in the data. I'm not showing it to you. Up. This gets a bit crowded now. We don't need this anymore. We also don't need this anymore. So let's figure out here. And VCC, what's the maximum and what's the recommend minimum? VCC doesn't exist. VDD maybe. That's the right one, but VDD, yeah, true. Yeah, VDD here, but that's the truth table. It's not the same. This is the truth table for if VDD is between 4 volts and 5 volts, but it doesn't tell me that it must be this way. This is just the truth table. Supply voltage, positive supply voltage. Yeah, come on, tell me the maximum voltage. It's probably 5. The maximum is 7. Does it work with something else? Characteristic, probably no. That's 5 volts. And still, the I/O work with 3.3 volts? Because I don't think this is 5 volt. Maybe this is this 5 volt operated, this microcontroller? Let me check. And the schematic again. Schematic reset 5 volt VCC. Ah, it is 5 volts. Okay, so this is operated by 5 volts. That's plenty fine. Ah, it's written here also. So you had this board existed in several flavors, I think. One with 3.3 volts and one 5 volts. I think with 5 volts you could operate it at 16 megahertz and 3.3 volt only 8 megahertz. And I've written here that this board is actually 5 volt. So everything is fine. Now we can connect it and it will work splendid. So we have ground in black, VCC 5 volts is white, is it? Yep. And then all the other colors. Chip select, this is the gray. Gray should be 10. This is 10. Then we have slave out, this is 12. And this is pink, pale pink, 12. Then we have blue, slave in. Blue slave in is 11. Up. Then we get clock green 13. And interrupt, it said pin 2, digital 2. You could also write it without interrupt, but although, is it important? Oh, this is the wrong pin. Is it important, the interrupt in this case? I don't know. We don't need ground. Does it say in the article which colors are what? Don't connect it to these pins. Does it say it? Does it say? Let's check the article. And let's get the code actually. So, copy. Let me show you what I'm doing. Full screen. Yep. Data projects 1 is done. Yep. And then we have, what is 22? 06 here, firmware, kind of firmware. Let's make it the binary here. Vim, it's forum.hex. And here is the hex file. That's it. And normally we should be able to flash it. Let me get this board, a cable, and I don't know if I have the tools. Let's check. AVR dude. Do I have it? Yes. I don't. It's been so long since I've used it. How does it work? Oh yeah, you had all these bits. I don't remember all these bits. The port. Wait, how did it work? Ah, you have to write it. You have to write using the bootloader. I don't remember. Maybe I did. Let me check something. I probably did something very similar. I did write some code for this platform. It's just been ages. I should have a template with it somewhere. Spark counter used it also. Spark counter at Mega 328. Yep. I think here I've used my own bootloader. Arduino Nano, blah blah blah. Normally in the make file, Arduino Nano, make file, I probably have here. That's the command. Let's test it out. Up. Understood. Okay. Device is what's the name? A28P or at Mega 28P? Let's just copy it. Up programmer is Arduino. Programmer Arduino. Okay, maybe. Port is USB 2. Dev TTY USB 2. And that should be it. Download, and then you provide the hex file, right? Flasher. Let's check how the flash are. Ah, here. You say in flash and then the hex. I don't know what I stands for. -u. And here we provide from that hex. Is it this way? Maybe. Not responding. The programmer is not responding. Yeah, I don't remember if this... that might be a pain. I don't know if the bootloader is on it. Maybe it is absolutely not on it. This is why I cannot programming use the Arduino. And I need a programmer to tap directly using ISP. I should have it somewhere. Probes prog here. Here's my box with the programmers, and in there should be something to write. What is this one? AVR prog. Oof. I don't remember this one, but seems to be fine. AVR ISP. Okay. This is not able to trigger it, so we'll have to programming using programming ports. Sorry, you don't see anything. But much I'm doing in front of the computer. This is ground, this is pin 1, this is VCC. Okay. Now I connect this and USB ISP. USB ASP. Does it tell the ports? No, there's no ports, so maybe I don't need to provide a port for this one. And I don't remember how I say. Let's try USB ASP. Does this work? Yeah, it works. Okay, flashed. Do we have some serial debug output? Maybe. Let's test it. Picocom. I don't know the baud rate though. Yeah, because it's a hex file, we don't know what it does. Is there a reset button? No, this is not a reset button. No. Let's try if we program it. What does it say? No, nothing. Maybe I have the wrong baud rate though. But I would see some things, some garbage, or I don't know what. Okay, it doesn't provide any output. The LEDs, does it have an LED? It's power LED. I also see on the board that it doesn't send anything over USB, over a UART. Now the question is it actually working? How can we test that? We can test it by tapping the SPI and see if the SPI has some activity. So let's open the oscilloscope. Is the oscilloscope connected? Can I show you what I'm doing on the oscilloscope? Maybe. Osci capture tries to capture, but it is not connected to a network. I know why. I think I've reused, yeah, I've reused this Ethernet connection for another project. Let's connect it back. But it's weird that I didn't reconnect it. No, it is there. Why doesn't it get an IP? Doesn't get the right IP, maybe? Okay, now it's connected. Okay, maybe it was too long. Does it work? Let me show you the Osci. And for that, I need to switch to bench Osci. Yeah, now you see the oscilloscope, and yeah, it is updating. Channel 2, we put it back in DC. I was doing some audio, and with audio you probably often need bandwidth limit 20 megahertz, so we have less noise. Switch to auto, no, first auto trigger. Let's get a probe for channel 1 up. And if we connect it between ground, if there's a ground somewhere, this is this ground? Yeah, this is ground. And let's just try the chip selects. Up ground, and oh, the clock. The clock will probably be a good idea, a good indication. If this works. This is pin channel 1. Now it needs power, so we need a cable to provide power. Up. And it is cluttered. You need to see a little what I'm doing. Up, up. Up. Power. There was some activity, but briefly. It didn't hold for long. Let's put back to normal. No, there is no activity. Just when it booted there was, but okay. When it boots there is activity, but that's it. Else it doesn't send clock. Maybe it waits for interrupt. No, I think it's always sending something. It doesn't wait for any communication. Else I would see some communication here because I put it on the oscilloscope and I didn't see any activity on these pins. So maybe the code doesn't work. Maybe it needs another bootloader, or I don't know. But it's not giving any UART output, which is rare, because you often want some debug output. And it's not sending a clock. We can try with chip select, but I think it would be the same thing. Although let's use channel number 2. Maybe it's just the fuses which are wrong. I don't think so. So channel number 2 of the oscilloscope. I don't connect the ground. The ground loop is super high, but should be good enough still. Chip select done. Why isn't there a reset button? And if we go to auto, wow. the noise. Yeah, there's plenty of noise because it didn't connect ground. Connect ground, there's less noise. But there's no activity also on this chip select pin. So this means that the firmware is probably not working as it is. We could disassemble it, but we don't have to, because that's a bit of a shame though. Let me put this here, because in maybe no, I didn't connect this wrong. So here later on, someone here wrote this. I took the hex from now what did you display? Text we go for. So here there is that. But there's plenty of other, so I'm not sure if this is the last one. Let's check on the last page. Just let's use the last code. Arduino clone, MCP that we have. Here's the code. And here we see serial print. So we should have a print. Let's try this. I don't think I have the Arduino installed. No, I do. It is installed. So let's try it. Arduino up. And we probably need the library for having MCP. Tools, phone board, we have this one. Tools at Mega port. What is this updater we don't need? Burn bootloader. Programmer, we have this one. Do we want to burn the bootloader? Maybe. Why not? So let's connect this. Although I don't have to disconnect, I can leave it connected and just need long cables for the bootloader. Up. The debugger is here. Pin 1. That's it. That's pin 1 and that's ground. Yeah. That's debugger. I'll put it here so we can see something. Now we just need a cable to connect the programmer so we can actually burn the bootloader. And although we don't have to, it's probably useful for the future for other projects which require this bootloader. Up this way. So the port is USB 2. 1 and 2 are for the multimeters. Programmer, burn bootloader. Does it or not? Ignoring mismatch is used. What device to prevent this warning? No. Although I don't. No, I'm not doing anything. Why are you complaining? Mismatch verification, double check with datasheet. What the hell? USB, that seems right. I have this one. Do I have to say get board info? Unable to sketch. Yeah, that's okay. Burn bootloader. Failed. Mismatch in unused bits of lock. Well, then burn the. I don't know. Burn the. You have a connection to it. Just burn it. You can rewrite the bits, the configuration bits. Oh, it doesn't see any connection. let me check if I can read the fuses. How does this work, reading the fuses? Up, up. There was something EEPROM. This is to read, and this is yeah, flash fuse. Okay, this is how to flash the fuse, and this is how I flash my bootloader. So this is probably how I could USB. I used the USB Tiny. I didn't use the USB ASP, but the USB ASP should be plenty sufficient to do that. What is -U mean? -U is flash it also. Low fuse. Do I just need to rewrite the fuse? That's it. Yeah, dude. Let's read the fuses. Where is this? Let's try if we can do it ourselves. You didn't see what I'm doing. Sorry for that. Full screen. Here. So instead of writing, let's read the fuse. How does reading work? Is it just read? USB ASP, so it means I have a Tiny somewhere. Device, IT Mega 328p. Immediate format for outputs, yeah. How does reading work? So port, yeah, blah 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 blah. Port, what does -U stand for? It means take an action. -U here, perform memory operation. Memtype, operation, file name. Instead of a file name, can I put minus? lfuse.bin. Let's try it this way, just up here. That's read, and then we need this is lfuse, yeah. lfuse.bin. Let's do it this way. Cat or is it? It's a binary file. Lfuse is probably 1 byte ff. Okay, so it probably shouldn't be ff, because here it says ff and it needs 3f. So maybe we just need 3f here. Why can't you do it actually? Okay, this is weird that you are not able to flash the things. I don't want to check what it does. What these bits mean. The problem is that there are not only the low fuse, there are also the high fuse and so on. Let's just write the low fuse for now. Maybe the E fuse and so on are the same. Let's test it. No, I won't be able to brick it, and even if I brick it, I have something to rescue it, I think. So here they want 3f instead of ff. -U. Okay. Writing eFuse failed. Yeah, I don't know what the eFuse is. Don't care. Let's try if the Arduino now can flash the bootloader. No. No. Do I need to find a command to flash the bootloader? Come on. Here, let's try to read it again, and let's see. Now FF. Okay. Why didn't you change? Why don't you verify? Do verify against verified. Okay, it says that it verified. So why do you say that this is still FF? Although I did ask 3F, you said written, verify, verified. Input file. No, okay, that's not input file. Right, so why, when I read it again, writing output file and fuse it bin, why is it FF and not 3F? And why is the LED blinking? This is weird. And now the firmware is doing something. Okay, and the oscilloscope, you could see some activity. Let me show you. Bench here on the oscilloscope, you can see sometimes that there's a switch. Okay, the oscilloscope is not fast enough. Let's put it on normal mode. Here, nanoseconds is probably too small. Let's switch it. It does something, it just reboots maybe. This is a bit too much here. Let's try it triggered. You see, it does probably, this is not a clock. It's far too slow to be clock, but there is some activity. Does it say something? Picocom? No. There is something running. It's blinking. You also, yeah, you can see it. The board is blinking. It does something. I don't know what it does, but it does something. But it's not. Why is there not a reset button? This is a reset button, isn't it? Yeah, this is probably. Check the data sheet. Is this a reset button? S1, and they just didn't name it reset, they just named it S1. S1 ground reset. Okay, S1 is a reset button. Why don't they name full screen? See, S1 is a reset button. Why don't they name it reset? But even if I press on the reset button, we have nothing on the output here. Let's check another board rate. I don't think it's too important. Let's press on the reset button. No, no output. The firmware does something though. I don't know what it does. And I don't know why I can't burn it. Let's try again. Let's write this. Device input disparate warning is bit. Double check with datasheet. Okay, that's the same thing. It failed to write. Reading. Do I need another microcontroller? This microcontroller shouldn't be broken. Device signature probably. So this corresponds. This is right. Now if you read again, let's read the low fuse. Let's output it. 3F now. Oh, this is already advancing. Okay. Let's try to burn the bootloader. No, it's still there. It's nuts. This is. Can't you show me what you? Can't you show me the command? What you're doing here? Then I know what's happening. NVIDIA Jude Flash Arduino bootloader fuses. Fuses. Installing Arduino bootloader. Okay, so the E fuse, blah 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 blah. We're using this. That's fine. That's fine. Now give me examples. Okay, this is if you want to flash it with another Arduino. The fuse bits will not work on this board. Okay, I don't have these boards here. This should be the fuses. Low fuse FF. So they were right. Hex file. Once the fuses are bit, you can flash compiled hex optiboot. Okay, let's try to find if we have it. Yeah, it is here. You lock. Why lock? Why are you locking? Arduino ISP Pocket Programmer. Let's just find this. Let's try this out. We don't have the tiny. I do have a tiny, but we have the ASP. Not sure if it's better or not. And if it doesn't work, we can still switch to tiny. Baud rate, we don't need. Ugh, what's all this? Ah, verbose, that's why. Okay, now it said everything is okay. And now we can flash the firmware, probably. Yeah, copy pasting without checking what it does. I think it's fine. USB ASP. I don't know why it says what it puts. Might put logs file. And here the hex is this one. Failed. Very good. So, erasing chip reading for flash. It does flash, verifying flash. It did verify 502 bytes for bootloader. Super optimized. Writing 1 byte log, verifying against. Okay, so the lock doesn't work. What is this lock? I don't remember having a lock byte somewhere. I remember fuses and so on, but I don't remember lock bytes. I need to disable something. Down. Just let me switch my Wi-Fi down so it only uses the Ethernet card. Okay. What is this lock thing? Can we still flash it? Oh, yeah, let's try. Let's just try to flash an example, a blinking example, sketchbook, examples, basics, blink, blink, upload, upload. AVR programmer not responding. Are you still using USB 2? Yes, it's probably still USB 2. I did not change it. Oh, pressing on reset. No, now it's blinking. You see this double blinking? I don't know what it means. But it means that code is running. This is weird because we erased everything and we put the bootloader only, according to to this command. So the bootloader should be doing this double blinking. So the bootloader should be accessible. Do we have something which uses USB 2? I don't think. No. This is. Yeah, we see this lock byte is weird. We don't need this anymore. We only need blink. Let's try to burn the bootloader again. Warning mismatch, don't care. And that doesn't work. Do I need to completely erase it using another programmer? I'm too lazy for that. Ignoring mismatch in unused bits. What is this lock byte? I don't remember this lock byte. AVR, Jude, erase lock byte. How can we erase a lock byte? Fail to reset lock bytes. How to set lock bits? What are the lock bits? Did I lock my microcontroller? Lock. I never used this lock byte. Chip erase, but we did chip erase. Can only be erased to 1, and then afterwards you erase it to 0. Let's have a look at the data sheet. Data sheets. MCU completes. It says a page. Where is it? 328. Here 378. That's somewhere here. That's weird. That's new characteristics. Lock. Not clock, just lock. Memory flashing. Maybe I just need to provide a chip erase in the beginning. Provides 2 lock bits. This is to lock the bootloaders. And if the bootloader, yeah, okay, let's do a chip erase. Yeah, I don't, I'm going on a tangent, but that's how electronic projects are. Can we have a chip erase? Perform chip erase. Okay. It does perform a chip erase. Everything should be set. Chip erase. Okay. And lock. Oh, delay. What's? This is the pages size 1. Okay, but it doesn't read it. Erasing it. Auto sets. Thank you, AVR done. So we should be completely erased. And the lock bytes should be also erased. Let's read them. Read lock.bin. Yeah, chip erase we don't need anymore. We did it already. Anymore, yeah, found. Don't care. And the lock is FF. Okay, so the chip erase worked because everything is set back 2F, which is written, where is this? Here. 111 unprogrammed. So the lock should be plenty sufficient to program it. Let's try again. Update log write 0F, and you can set it to 0. So 0F, what does it mean? Here, 0 means that this and this are locked, bootloader 11 and 12. And the other ones are not locked. What is 11 and 12? 11, 12. 11, 12 here. It's not allowed to write the bootloader section. Okay, an LPM execution seems to be right. Ah, it's 1.1 and 1.2. Okay, because it's bootloader bits, bootlog bits 1 and 2. Okay, so let's try to lock it. And it doesn't. It says CF instead of 0F. So it's not able to lock. Why is it not able to lock? No erase, just lock. If you read it, do we need to unpower and repower it for the lock bits to be, maybe that's it. No, because the erase worked. Oh, let's check. Let's read the lock. CF, yeah, it didn't work. Let's unpower and repower it and see if this worked. If this works. Unpower, repower. This is still USB 2. And now can I write the lock? I also need to repower my programmer. Actually, I don't need this for now. So we don't need USB 2, no powering. Okay, now that's reading, sorry. Writing now. Writing doesn't work. Why does writing the log bytes not working? Fuck. To prevent this warning of unused bits when writing, double check datasheet. Ignore mismatch. I think it's not locked, but who cares? The bootloader is on there. It's just not protected. So we should still be able to flash it. No idea why it doesn't allow me to lock. So, uploading. It's already taking too long. So the bootloader also doesn't work. I have no idea why. Nobody's using this port, so it should be plenty sufficient. Tools, burn bootloader, mismatch. Come on, come on. I just want an Arduino to be working. Is that so hard? And it's even an original board. Oof. Do you want me to use another not original board? Let's try another programmer. Maybe just, no, I don't think the programmer is the culprit, but I don't want it to debug much more. So let's just use another programmer. This is the tiny ISP. I don't remember. I have two of them. No, there's something else. What is this? So many boards. I have two of them? Didn't even know I had two of them. This is something else. This is just... It's actually not a programmer, is it? Start streaming. Yeah, so I have no idea why, but yeah, my Ethernet dropped. But I'm back. So let's use a tiny ISP. Is it that? Power target, power target. What is this board? If I connect it, what does it say? It says it can read this USB device. This is good. No, now it can read it. And it doesn't say what it is. My devices, which one is it? Optical mouse. It did say ID 0C9F. This one, USB Tiny. Okay, let's try with the USB Tiny. If the ISP doesn't work, I'm sure this is not the issue, but who knows? Up. Maybe it doesn't work because I have, no, I don't think this can be possible because I have the thing programmed. I don't think so. Pin 1, this is pin 1. Up. So let's try to flash it using USB Tiny. Update USB Tiny. And it also fails. Very good. So it's not because of the USB ASP, it's because, I don't know, the microcontroller is dead. Oh. Yeah, USB ASP doesn't exist. USB Tiny. It's getting annoying. So you cannot set the lock. Do I need to have another of these Atmegas? Maybe this Atmega is broken? I wouldn't know why. Let's try also now telling we have a USB Tiny. We see that didn't matter for USB Tiny ISP. Tool, burn bootloader. No. Come on, this it's not even true, is it? Low fuse. I need to read the low fuse. Which one was reading the low fuse? Read low fuse. Why? What? Target does not answer. Let's unplug this. Up. Why does the target does not answer? Do I have to set the bit rate like they said? -B1920. Was it that? Something like that? USB Tiny VE. Does it power the target? No power. Power. No power. Power. There is a power LED, so it does power the target even if I put it on no power. Target does not answer. So the target is completely dead now. Now the target answers. 3F. Why do you say that this is not 3F? Let's write the medium. Is it medium fuse and then high fuse? No, okay. Maybe there's just a low and a high fuse. You didn't write it? Yeah, it's invalid signature. Okay. Invalid signature. This chip is dead. I have no idea why, but this chip seems to be completely set. Okay. It's not even able to. It is power target. It's on power. Repower it. That helps most of the time. And now it works. I have no idea what's wrong with this board. DA. Did we want to write DA? High fuse D6. No. Let's try this. Failed. Okay, this chip is dead. Let me find if I have another of these. Microcontroller, else we will not use dual, we will use something else. Atmega 228p. I have one of them remaining. Bench. No idea what's wrong with this one. If it works immediately with this new one, then we know we have a dead chip. I have no idea why, and I don't bother. I want to do CAN. I don't want to do that. Let's unplug power. D2, no, and this shouldn't interfere. No, the programming pins are completely separate. Up. This is gone. Pin 1, pin 1. This is, yeah, also same microcontroller. Up. Up. Let's check. Let me switch off the oscilloscope. Also because it's not updating. So let's try again. Screen, full screen here. Let's try if this works. This also didn't work. It says erase, flash the fuses, and it also fails. So I don't know. Unplug, replug to repower it, but it has the same issue. So the chip doesn't seem to be dead. It's something else. I don't know what it is. The bootloader. Let's flash the bootloader. I just don't care at this point. The bytes are verified, but we have the same issues. Okay, so it's not a problem of the programmer. It's not a problem of the microcontroller. It's probably a, I don't know, a problem of the board. What if I disconnect the power from this MCU? Okay, now this doesn't work anymore. I do have a high voltage resetter. Okay, now it doesn't detect it at all. Power is here, and it doesn't detect it. not hardware I want to do. Just want to flash an Arduino program. Not even able to do that. Oh, okay, there's a tiny error connection. Ah, no. Does it use... Okay. Does it reuse these? No, I don't think so. Does it? Let's disconnect that. Oh, let's put some tape so we know how it works. And let's do pin. Let's disconnect that and that. And let's check it again. No, it still doesn't work. So this is not the issue. I don't know what the issue is. The bootloader should be there. Let's try to flash a programmer using the bootloader. AVR Dude. We did try it. Let's plug a USB up. Let's try to flash over USB. Flash the bootloader over USB? No, no, flash something else. Is there the blink which is compiled somewhere? Just compile it. Done compiling. Where? Don't you want to tell me where you compiled it? Ah, no, you don't want to. Let's upload it. No, it doesn't upload. Why is it so hard to work with an 8-bit microcontroller? Why? Save as here somewhere. Yeah, save it here, I don't care. It saves only the... In this folder, it only saves... Where do you save? This is verified. Don't you compile it somewhere? Verify compile. Where do you put this compiled binary so I can flash it myself by hand? Oh, I hate Arduino. I hate it. Here's the... What the fuck? Export binary. Okay, now it's exported. Let's try to write it. Using the bootloader, maybe. Let's try with the bootloader. Right, and it is in home Arduino Blink, and there is a hex with bootloader. Huh. Let's try to flash it with the bootloader. Oh, you don't have to erase the chip. Verbose, yeah, why not? Programmer, yeah, USB tiny, why not? Or not. Is not readable. Are you shitting me? You don't know how to resolve home? No, it doesn't know how to resolve home. Ah, but the double blinking. The blink works. So we can flash firmware by hand. I don't know why we cannot flash it using the bootloader, but we can flash it by hand. Good enough for me. Let's continue with that. And it did start. And let's try another one. Examples, communication. I just want hello world. Is there some hello world? Digital, T-bounds, communication. I just want a hello world. Strings, display, USB keyboard. No. Serial event, serial call response. What's this? Read and it responds. Establish contact. Hey, I have no idea. What is this? Patch run with this example? What the who cares? New. Up. Let's get the example now from this site. This one. Up. New sketch. Okay, here we have the messages which it sends. So, what does it do? Setup. It sets up USB, the serial. We probably need to install this. I don't have this library. Manage libraries. Max speed. Oh, you can set the max speed. So it did. They decoded one message. They didn't decode all the message, but they decoded one message. Can type. Arduino. Okay, low power. Topic. Communication. Arduino. Can. Okay. MSP 2815 maybe. CP. I don't know. No, it's MSP. Okay. Can, but it's yeah. It just uses this word with can. That's not the one I want. SPI. Maybe this way. MCP can. That's MCP can. Because the library is called MCP can. Yep, but there are several ones. There are plenty. Which one do I need? Oh. Yeah, tell someone that Arduino is easy. So many libraries probably all doing the same thing. Let's just try can. Installed. If it doesn't work, we'll install everything. File, save as. ES400B. Verify. Okay. Can, no such file or directory. Which library is providing this? Arduino. MPC can. They even provided here. Don't tell me that I have to fork from there. So I need to use this myself. Releases. Okay. Source code. Yeah. Who says that Arduino is easy? It's not. Up. Downloads. MCP can. Arduino libraries. Extract here. Seems fine. Let's see if it works. Done compiling, but it's not the right one. This one. Okay. I probably copied something wrong. Compiler error. Where? 51. But it's nothing to do with me. Please submit a bug tracker. Error compiling for board. Who cares? Why? In function main. Okay, so here somewhere there's some bracket which doesn't seem to be closed. Setup. This everything if okay, I hate that, but it works. This works. This is fine. This goes back here. This goes back here. So why doesn't it work? Maybe because of the library. Please submit bug report. You don't show me the line numbers, so we don't even know, but it's not in my, it's my Arduino core. Do I have to just tell that I have some nano and then you're happy with it? No, because they compiled for the nano. Or do I have this one? But that doesn't seem to be the error. Set CS to pin 10. Why don't you work? Why don't you work? Let's try to. So here what it does, it sends error sending message. It just sends the messages all the time. Okay, let's try to erase and see if it works. It compiles, so it's something with the code. Where is it? It's compiling, so it's something with this code. Now it's not compiling anymore. Okay, 4. Let's fix this, else this goes here. No, 29. Okay, this is hard-coded because it's here 29. But yeah, you should not use this. You should use a constant somewhere. What if I write this? Okay, so you're complaining, that's okay. It can compile. It's just a message send buffer, this thing which doesn't work. And then it's because of this stupid library. Very good, very good. Byte 0, let's try it out. No, that's not the issue. ID The print line on the ID doesn't work. Why are you printing IDs? Print uses a format string. That's not a format string. The fuck? Why? Do it this way or X, because yeah, just send a hex. This is a long. 08, something like that. We have an on-site long. Why am I not allowed to print a hex? There's something wrong with my C. Unsigned long. If I get the integer, we have a long. LU, this returns a long. Const char, sure. Ah, this serial print doesn't accept. Doesn't? Seriously? This print doesn't accept format strings? Nah. I can't believe it. No, it's println const char 4. Okay. No matching function for call. Okay, there is a. What the? I know. Serial prints doesn't allow format strings. Printf 08x new line. Okay, let's do it the Windows new line too. Printf doesn't exist. Come on, what? Who wants to use Arduino? Examples. Communication. Graph. Print and analog read. Print line is able to print directly values and not only strings. Why? Okay, it wasn't wrong how they used it, because it doesn't use a format string. But it's weird. Okay, we will just try something else. We will do print of the index. Print line, weird C++. Now it compiles. I'm happy with it. I don't care about the IDs. Export compiled binary. Okay, now it is exported. Now I can flash it and I can monitor the output. Let's do it one at a time. USB 2. Okay, let's flash it. It's not blink, at least. Yes. Come on, I asked you to export the binary. okay. Standard hex. Okay, flashing, verifying, reset, error sending message. That's good. The firmware sends something. Up, you are powered. You are going here. You are on pin 2. And now you should be able to send messages if I reset you. And you're not. Did I get something wrong? It does send something in the beginning. Initialize successfully. Why aren't you setting baud rate successfully? Initialize successfully. If you initialize successfully, why can't you transmit? This is weird. Maybe it waits. There is some activity now. We see a clock and a chip select. So it does try to send something. You're not seeing it. Let me show you on the oscilloscope capture. It should be capturing. Let me show you on the bench. Oscilloscope, here you see some traffic. Once we have the clock select, and then we have the clock. Yeah, this looks like a clock. It's a pretty fast clock. 8 megahertz, okay, that's pretty fast. And then the clock selects and you are transmitting 3 bytes. How is it? Yeah, 8, so 3 bytes. Sometimes maybe more, I don't know. But yeah, you're always transmitting 3 bytes. This is one thing. So now we could test. So we have this output. Now, which one does it say in the tutorial? Which color is which pin? I don't know why it says error sending message though. Let's put it here. Let's check in the forum if it says where it is. Connector, what you need, okay, but you're not telling the colors. Are you? Full screen. Here, I'm looking for the colors of H plus and H minus. Interrupt on D2. Yeah. I'm doing it. Oh, is it? Does it use interrupts on this example? No, it doesn't use any interrupt. It uses CS on pin 10. Is this correct? CS is gray. Gray is pin 10. Okay, that's correct. Let's check the other ones again. And we see it also, the clock selected works. D12, oh, it says initialized work, so it should be fine. 11 should be Mosey. 11, blue. It's not Mosey, it's Miso. That might be why it doesn't work. I switched pin 11 and 10. Mosey, so that should be, no, it's right, okay. Slave input, that's okay. Then we have digital 12 is miso. This is whitish. Yeah, this pinkish whitish. Miso, that's fine. And the green one is the clock D13, D13. And it says that it's configured correctly. So that seems fine. Ah, let's add the delay here. And number of bytes. It shouldn't send only 3 bytes, it should send plenty more bytes. Message bytes I, message byte what? Message byte I. Okay, that's the pointer. Why do you provide it 2 times the same thing? That's the ID, that's probably the number of messages. Standard count frame. Length 8 bytes. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Data. Why are you providing it 2 times? Can I see how this is declared? No, I can't. I love that. Where can I see this library? Here. Okay, so send. Who wrote this code? This code doesn't, I don't know who created this code. This code, first it doesn't compile, and graph we don't need anymore. And this is wrong. Ah, no, it's right. Number bytes and message bytes. Okay, number bytes, but number bytes is always 8. Oh no, it's not always 8. Sometimes it's 7. Okay, no, it's my fault. 1, 2, 3. Why is it not always 8? Why is it sometimes? That's weird. Here, okay, 24. Number 24, it says still 8. Number 17, it says 1. 17, 1. Okay, just the first one. And then afterwards, you want to send bigger ones? This only zeros. 25, it's also 8. It's super weird. But this is okay. This is okay. We could check what is transmitted over CAN. Do we have a CAN decoder? No, we wanted to check first if it goes, if we find the pin which is described. Here, IDs, you can't print that. Somebody don't know how to, although I don't know. Okay, here it doesn't say the colors. We'll just try both configuration. Who cares? Yeah, this you can't do this. You can't do this neither. 3 position on off charge. No colors. Here, can no colors. Oh, here maybe, no, that's completely something different. Only 3 of the 4 volts are forwarded. Let's hear same batteries. We don't have 5 pins. Okay, no, we'll just try both ways. That's not the right connector. Yellow and green, does it match what we have? We have green and orange. Let's try it this way. Green is high, orange is low. Okay. So for now we will disconnect power while we are plugging it in. Let's switch back to the bench so you can see something. Bench. Screwdriver. Where are my screwdrivers? They are somewhere here. I think this one a bit too large. I moved everything here. This one. So what did we say? Orange, green is high. Let's try it. Okay. Let's switch it on. And no. We still only have 24 volts and probably, where's the resistor? I want to put a resistor between the two parts. Yeah. Probably also because the messages are not sent, we should capture CAN. That might be a good idea. Try to capture CAN. Something made click. No? No. My imagination made click. Where is... So we put this here. Where's the resistor? Here's the resistor. Let's put it between plus and minus. So we know if it's now at 0 volts. And if it's above 0, then we know that it works. For now, it's not working. Maybe the codes are wrong. I didn't check the output of CAN. Let me strip the wires a bit more so they fit better in the plug. And we don't have that many combinations, so we can try them all. I also didn't put any termination resistors, but I don't know if this is important. So, I don't need you anymore. Switch it this way, 1 and yeah, I should try if there's a CAN output. No, we still have no output. Let's try it the other way around. If it doesn't work, we will check if we have CAN outputs. Maybe when it says that messages are, it failed transmitting messages, might be right. Still nothing. So now we have to check CAN output. For that, we need the oscilloscope. I'm doing everything while it's running. Probably not a good idea. Probably. So let's disconnect this. Don't remember what J1 stands for. Goes to ground, does it? I don't know. No, I don't know what J1 says is for. Why don't they put a label on that? Up. Okay, so now we will put the leads one here. In theory, it's differential. It shouldn't be that shouldn't matter to have ground, but we will still connect ground. Up. 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 Now we have ground. Let's go to auto mode. Okay. Let's plug power and let's see if there is a CAN output. There is. Do I have a CAN decoder? Kind of, there is. It's far too regular to be something meaningful. Are we, so this is high, yeah, this is low, this is pretty fine. Decode, do I have CAN? Yes, I do. Signal type, baud rate. What's the baud rate? Does it say in the code? But the signal is far too regular. It's not transmitting something. Yeah, an error sending message. There's probably an error there. Don't know why, but so what does it say? 250 kilobits per second. Is this what I do? No, I'm at 400. 500, and we are going to 250. 250. Signal type RX. Ah, okay. Differential. Differential. How do you know differential? Channel, yeah, 1 and 2, both of them. Sample point. That's, yeah, sample point, pretty fine, 50%. And ASCII, no, we are putting hex. Threshold, okay, TTL, ECL, threshold 2 volts, 2 volts. Never decoded CAN on this thing. We really have to get the logic analyzer to find out what it is transmitting and how it is transmitting it wrong. This is definitely not. There's no 1 and 0s here. So, why doesn't it transmit correctly? The code seems right. CAN 0. CAN 0 is created here, MCP can SPI, print2 with this, transmitting. Can OK, can 0 begin, print, OK. Set mode normal. Error initializing else. I hate code which is written this way. Ugh. Completely not readable. Why do you want SPI though? This library should get SPI. It's not a... This shouldn't matter. And it doesn't. Who? I have the impression, though, I don't know how it got this code. Int. You int 8. Use small things, and this is not signed. What is 1? We did have the code, so we don't need this. We don't need this anymore. Here, ext, and here. I love. Oh, it's so well written. No doxygen, meaning what ext mean. Extension. If it's an extended message, is it? Let's have a look at the code. Register, set register, read, control, read, where is write? It's reading write can message, right? Send message buffer. Send message buffer, there are 2 of them, obviously. Len, okay, this one. Send message. It figures out if it's extended or not. What is RTT? RTR? There, you know that I don't know what how can works. Send message. So send message. Here, send message. Seems to be written okay. Let's read register. Send message. Which error does it send? Can't get TX. We have several errors. You're not seeing what I'm doing. Full screen. Here I'm trying to debug this code. We want to send this, and actually I prefer it this way. This way you can't accidentally assign. Compile doesn't compile anymore because you cannot print that because you don't know what it is. This is just an enum, right? So this println const prop, okay. You have to know what it means. Blink, we don't care anymore. This, we don't care. Okay. What type is this? This is an int. And you can't print an int. You can print something like that, but not an int. You int 8t. You can't print that. How does println work? You don't accept format strings. How do I do format strings on Arduino? Arduino serial print format string. Just print and not print F? Serious? Print. Okay. Hello world. Okay, F. Okay. This is probably to put it in flash memory. Why not? Value format. What? Decimal octal. Okay. As hex, as decimal. Just allow me to print format strings. Seriously. Does printf work? Do I have to do an ascend printf before I call serial begin while serial print formatted printf what's that? SCI, okay. SB port buff, SB reset serial. What's SB? SB. This is something else. You have to construct the format string yourself. There's no print. Wow. Wow. Okay. Binary or decimal? Let's put it in decimals. This prints. Let's do this. Put it in flash, although it's not a huge message, but why not? If we do it correctly, we save some RAM because we don't have a lot of RAM on these microcontrollers. F compiles, exports, and now we can flash it. If we connect it, where is my serial here? Up. It still says error, but at least it says the error. Error is number 6. What is number 6? Number 6, you probably have an enum somewhere, don't you? Here, probably. In the H. I don't know how C++ works. DFS? Here. Here can OK 6. This is get tx buffer timeout. Okay, this is why it's not able to send. And it is serial print 10. If debug starting mask. Okay, we are at send message. Send message here. Get next free buffer. And it waits for milliseconds. Why are you not transmitting? So it's probably not able to send. Yeah, if timeout get message, this is the error we get takes buffer timeout. So it's not able to get a free buffer. Get next free buffer. Where is this function? MCP25. MCP25 get next free buffer. Check all 3 TX buffers. If I reset, does it say something in the beginning? Yeah, 7. And then this is why it's full. 3 times 7 and then always 6. What is 7? This is why send timeout. So it's not sending it. Why are you not sending it? Yeah, 7. And this is why afterwards the buffers are full, because we only have 3 buffer as indicated here. And the 3 buffers are full, and this is why it gets the free buffer. So we have a send timeout. The send timeout is read message, no, send message. Send message. Here is the send timeout. It's read register and timeout, modify register. I don't know how this chip works, but what we could do, and this is what I wanted to avoid. We could re-implement, we have the messages. The messages are, these are the messages to transmit over CAN. What we could do is just use another microcontroller and not this MCP thingy. And this is why we already see 3 bytes, because it's only reading a status and not sending messages on the oscilloscope. Okay, makes a tiny bit of sense. Do I want to debug this code? Or do I want to implement it myself? Because if I implement it myself, I don't have to use this library. I could use just a microcontroller which can do CAN and send it over CAN myself. Write CAN message, and this is the buffer, so it writes it. So if we trigger the beginning of the message, we should see that it writes it, and somehow it doesn't send it. So send message, yeah. Write CAN message, modify register. And do I have the datasheet for that? Datasheet. I see this is a mic CAN, probably CAN. Here, this one. Let's put it in this thing. Ah, it's already there. That's not an IC, that's a dev board. Dev board. Here. Ah, we already had it open because we wanted to check the voltage. And it's not a long. It's so small. No, I can't package. This is just high-speed transceiver. I can't imagine 26 pages with all the commands. I see characteristics. This is the transmission. No, it doesn't tell the protocol. No, it's not. This is just the datasheet. Do I have the NUT datasheet? No. I have this chip, which I would use. I don't have the NUT datasheet. So let's try. Oh, is it the right chip which we are using? This is a 2551. And this is expecting 2515. I have the wrong chip. No, I just wrote it differently. It's not a 51, it's 15, which I have. It's a typo. 15 this way. And I don't know a lot of modules. It would be surprising to have the wrong one because there are not a lot of CAN modules. I don't want the PDF. I want the complete data sheets. Programmer. Allow. No, it should be right. Give me standalone SPI interface. That's the one I want probably. Okay, now we have the messages. Pinout description, blah, blah, blah. Standard frame. Ah, and this is the extended frame. But, so we are sending extended frame. Okay. This is a standard frame. This is an extended frame. Okay. Remote frame. I don't know, the frame error, overload, polarity. Here. Transmit flow message diagram. It's quite well documented. And here we have the messages. Let's put it on the side so I can check what the code is doing. Get next free message. Okay. Then it writes the message and it modifies the register. It's weird the way to do it. This is the data. This is the register to read. This is the register to write. Why two things? TX require modify register. How does this work? Modify register. Mask and data. Address. Mask and data. That's not what you're providing. Send message. Modify register. That's the address. That's not the address. Ah, maybe it's the address which you found. Takes buffer n. Okay, no, it is here. Write CAN message. Takes buffer n. Why n minus 1? Why not n? Ah, okay, because the address. Okay. This is the mask and this is the value. Okay, makes all kind of sense. Mask value and you write. I don't get what it's doing. It's reading where the next buffer is. Then it's writing the message to this buffer, and then it's writing, modifying the data in this buffer. There's something I didn't get. Here. Let's put it side by side. Up. No. This is the flow. So this is where it checks the arrays. No, it checks array. The message transmission sequence between for any registers has been set. Okay, this is not what you're doing. Highest priority message. Transmit message data flow. You have to clear. Is message but available to start transmission? It's not what you're doing. You're getting a free buffer. Transmit message. I don't know what it's doing. Okay, it's a bit more complex than I expected. Yeah, it's still saying can't send the messages whatsoever. Maybe. Why can't it send a message? 7 timeout, exactly. Get buffer timeout. Ah, the beginning. Oh, 7, sorry. 7 was. Where are the defs? 7. Send message timeout. Send message timeout here. Timeout value. Read register. What if we just increase this timeout value? Well, it's fixed. Where is this defined? Timeout value here. Is it millisecond? Let's double it and let's just try and see what it does. Exports. Okay, let's flash it. And if it doesn't work, then it doesn't work. Then I don't know what I'll do. Nope, same error. 7 and then 6. Let me show you because this will be the end of the stream. Here you see setting up baud rate, initialize, error sending message, and the error is 7. Then we get 3 timeouts, and afterwards we don't get any free buffer because the 3 are occupied and they are not transmitted. So that's the error. For now we are done. I don't know what I'll do. Either I'll try to debug this code or I'll just re-implement it using another platform, because in the end I probably will not use this microcontroller and this board to send CAN messages. I'll probably use another microcontroller with a CAN which supports CAN and a CAN transceiver and send the raw messages myself. What would be nice if to test if this code works before I re-implement it. But that doesn't seem to be the case here. I don't know why. But for now, the stream is finished. You've seen how I debug things. I'll probably do another stream at some point once I made progress and made a decision. But for now, it is done. So enjoy the rest of the day. Bye bye.